Yes, ma'am. Ma'am, shall we start now, ma'am? Ma'am, Vijay ma'am mute la irukku, ma'am. Please unmute, ma'am.
Shall
Shall we start now, ma'am? Start பண்ணிடலாமா? Sir, Anandhan sir. Okay, ma'am.
Am I audible, ma?
Yes.
we can start now?
Shall we start, ma'am?
Hello.
Sir, start பண்ணலாம் sir. You mute sir.
You can please start, ma. It's level 5 now.
Yes, ma'am. Sunshine is a welcome thing. It brings a lot of brightness. One small thought in the morning will change your day. A pleasant morning to one and all present here. The staff and the students of the postgraduate and research department of chemistry, Ethiraj College for Women, are glad to have you all with us for today's webinar. I extend a warm welcome to all for this national webinar on basic concept of electro-organic synthesis. Let us begin this webinar by involving the presence of Mother Tamil with Tamil Thai Varthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத்த கண்டமிட்டு எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Baby, look.
People are either born to host to receive welcome or born to be guests to receive welcome. Now, I would like to invite Dr. R. Manonmani, Assistant Professor, Department of Chemistry, to deliver the vote of thanks. To deliver the welcome speech.
A very good morning to one and all present here. I take immense pleasure on this occasion to welcome our chief guest, Dr. R. Anandhan, Department of Organic Chemistry, University of Madras, our beloved Madam Dr. S. Kodai, Principal and Secretary, Head, Department of Chemistry, Mrs. M. Vijaya, Head in Charge, Department of Chemistry, Senior Faculties, my dear colleagues and students. On behalf of the PG and Research Department of Chemistry, Ethiraj College for Women, I extend my warm welcome to a registered participant. I would like to call upon Principal Madam to speak a few words. Over to you, ma'am. சார் சாரி ஃபார் இன்கன்வீனியன்ஸ் சார். ஒரு 2 மினிட்ஸ் சார். நெட்வொர்க் இஷ்யூஸ்னால மேம் வந்து கனெக்ட் ஆயிட்டு இருக்காங்க.
Sure, sure. No problem.
சாரி சார். தேங்க்யூ சார்.
No issue.
தேங்க்யூ சார்.
அவர் போயிட்டாரு சார் போயிட்டாரு.
Okay, why is correct? Yes, ma'am. So sorry for the inconvenience. So now I would like to call upon Dr. Mrs. M. Vijaya, Head in Charge, Department of Chemistry, to speak a few words. Over to you, ma'am.
I'm audible, sir.
Ma'am, audible, ma'am. Yes, ma'am.
On behalf of the management and the Department of Chemistry, I extend a very warm welcome, sir. I also extend a very warm welcome to the participants who have registered from various institutions. Wishing all of you all the very best. Thank you, sir.
Thank you, ma'am. It's a welcome gift to encourage others to achieve greatness. I would like to invite Dr. R. Manonmani to introduce the resource person of today's webinar.
It's my pleasure to introduce our chief guest, Dr. R. Anandhan, for our national webinar, Basic Concept of Electro-Organic Synthesis. Dr. R. Anandhan completed his MSc degree from Madras University in the year 2005. He obtained his PhD from Madras University in the year 2011 and did his postdoctoral research during the year 2012 to 2014 at National Tsinghua University, Hsinchu, Taiwan. Dr. R. Anandhan joined as assistant professor in the year 2014 in the Department of Organic Chemistry, University of Madras. His research expertise are visible light photocatalyst mediated organic transformation, electro-organic synthesis, asymmetric synthesis, transition metal catalysis, and supramolecular chemistry. Dr. R. Anandhan has received many funded projects from both central and state funding agencies. He has guided and guiding many PhD students. Dr. R. Anandhan has published many research papers, review articles in reputed national and international journals with good impact factors. He has delivered many lectures at various national and international conferences, seminars, and received many awards. To mention a few, Young Scientist Award in the year 2015 from DST SERV, Mr. Ramachandra Rao Gold Medal Award for Best PhD Thesis in the year 2012 from University of Madras. It is really great honor to have you with us today. Thank you so much, sir, for accepting our invitation and willing to share your research knowledge. Now I invite Dr. R. Anandhan, Assistant Professor, Department of Organic Chemistry, Madras University, for his presentation. Now the session. Over to you, sir.
Yeah. Thank you, Dr. Manonmani and Dr. Vijaya, head of the department, for your nice introduction. So, shall I go for presentation?
Yes, sir. Yes, sir. Shall we move, sir?
Is it visible? Is it visible?
Sir. Yeah, yes, sir. Yes, sir.
Yeah, thank you for giving this opportunity. So today what we are going to give seminar in the entitled on electro-organic synthesis. So what is the electro-organic synthesis? So this is the, everybody knows that the master students knows that electrochemistry they know, and organic chemistry knows. So what is the merging of electro-organic synthesis? So that is we are going to see today presentation. So what is the first, I'm going to focus about what is organic chemistry. Generally we know that what is organic chemistry. When you are performing the reaction, just I will take it pointer. Okay, so when you want to do organic reaction, need to take it to substrate. Either you have to take it one substrate and need to add one more substrate, so that will give the products. So the product may be one product or two product or three products. So these are the general reaction of organic reactions. So taking off one substrate and addition of another substrate, it is getting the product. So this is the general way of organic reaction. Generally this substrate, most of the substrate has solid in nature. So can we, when you are mixing of two substrate, so whether reaction is going to happen when it is liquid state, it can possible somehow, because when you are taking off substrate 1 and substrate 2, shake it by shaking or whatever the way you can make it the product. But the possibilities of taking liquid of substrate 1 and substrate 2 are very less, because that liquid nature of the substrates are very less. Even though if you have that liquid nature of the substrate and shaking, so while shaking the reaction is going to happen. So that is another question mark. So what is another way that most of the substrate has solid in nature? So can we mix it two solids shaking? It's not possible, because there is no reaction, because that physically it is different in solid in nature. So there is no connection between of substrate 1 and substrate 2. When the reaction is going to happen, when that activation energy barrier is reaches to highest energy, then only it is going to the product. All the two substrate need to reaches to highest energy level, then it goes to the product. But when it is two solid substrate, it is the reaching to highest energy level is not possible. So in that case, what you have to add, you have to add solvent. So why we need to add this solvent? Because this solvent to dissolve the substrate 1 and substrate 2, make it in homogeneous medium. So this solvent will helps to make it interaction of substrate 1 and substrate 2, bringing to this homogeneous medium. So then the another question is whether that when we are dissolving or making of the homogeneous medium, whether the product is going to form. So that is another question, that it is most of the reaction when the taking of substrate 1 substrate 2 dissolve in solvent, reaction not going to happen, just it is going to be dissolved in nature, that's all. So when the organic reaction is going to happen, so either you have to add a catalyst or reagent. So why these catalyst and reagents are needed? So this catalyst or reagent is going to activate these two substrate to this activation, highest activation energy barrier. So this catalyst and reagent is going to help these two substrate to reach us to highest activation energy barrier. Of when it is reaches, these two substrate reaches to highest activation energy barrier, so it is getting the product, then it is going to lowest energy state. So this is the one, the activation energy barrier we have studied, we could study it in UG and master level. So when we adding of catalyst and reagent is enough? So that is another question, that sometime the reaction is happened at room temperature, so we need to stir it. Stirring is needed, yes, sometime, or sometime we need to heat it up. We need to heat, or if reaction not happening at room temperature, we need to heat, either heating is 60 degree to 200 or 300, or whenever how much heating energy is required, we have to heat it. So by heating of the heating, the activation energy is going to reach as highest, then new bond formation or new product formation is going to happen, then it reaches to lowest energy. So or sometime it is needed light energy. The light energy is going to activate the activation energy barrier, then we will get the product, then it is going to be. So these are the general way of organic reaction. So organic, when you are performing the organic reaction, you need to have two substrate, and sometimes need a catalyst, or sometimes need a reagent which is dissolved, all this one dissolved in some solvent is needed. Apart from this, we need to have either we are going to room temperature reaction or thermal reaction or photochemical reaction. So these are the way, generalized way of doing organic reaction. So can we replace of this catalyst and then thermal and H nu? Can you guess? The without catalyst, without reagent, without thermal heating, without H nu, can we do the reaction? Or can we replace any system for replacing of catalyst or reagent or thermal or H nu? Anybody knows? Guess something? Yes, sometime the electrochemistry is nowadays is going to replace the all the catalyst and reagent. So what is the electrochemistry? The electrochemistry is going to replace the wherever the requirement of catalyst or reagent, or that is sometimes there is no need of thermal energy or photochemical energy. So what is electrochemistry? So how it is going to be replace the catalyst or reagent? So that's we are going to see that our today presentation. How it is going to be replace the electrochemistry. So this electrochemistry, we know that, so we could study it in UG and master level, that we are studying extensively in master level. What is electrochemistry is that the electrochemistry is the one is electrode. So these are the electrode is keep it, one is anode, another one is cathode. So this colored one is that solution which is dissolved in substrate 1 and substrate 2. So when applied when giving off applied current, so this electrochemical reaction is going to be happen over here. So what is the where that catalyst is going to be replaced? So this electrode is going to be replaced that instead of the catalyst or reagent. How the reaction of these two substrate is going to happen on the surface of the electrode when the applied current is passes to during this process. So that this substrate 1 or substrate 2 whatever the substrate is going to be reacted on the surface of the either anodic electrode or cathodic electrode, wherever it is going to be takes place, then further it is going to be reaches to this activation energy barrier, then you'll get the product. So this electrochemistry, the recent years, this electrochemistry is going to be replace the all the catalyst, all the reagents, or sometime it is going to replace that external energy like thermal or H nu. So then what is electrochemistry? So what is electrochemistry? Electrochemistry is a branch of chemistry deals with chemical reaction by applied current or potential. So we are doing chemical reaction by applied current or potential. So these when applying of the current, it is passes to on the electrode. So that electrode is taking place the reaction on the surface. The electrode is going to reaction is going to takes place on the electrode surface. So that's why this electrochemistry is going to be booming recent years. I think after 2021 and 22, so everybody start focusing on electro-organic synthesis. So these electrons are flow in between of these two electrodes. During this electron flow, the most of the reaction is redox reaction is going to be happened. So this is the electrochemistry. So why we need to do electro-organic synthesis, because we know that we are not going to give any harsh condition. We are not giving thermal energy or HNU energy. So we are doing electrochemistry under room temperature, ambient temperature. So that's why we are calling the reaction medium and mild reaction condition. So it is very, very ambient condition. And another one, we are going to replace of stoichiometric amount of reagent and catalyst. So we are not so because most of the reagent and catalyst are very, very expensive. So we have to replace, somehow we need to replace. So this electrode is going to be replaced on these reagent and catalyst. So these are the environment advantages of electro-organic synthesis, and it is going to be environmental friendly. You can see that we have lot of energy sources we have, right? Fossil fuels or light energy, whatever that we have, uh, huge of energies. Just you can switch on the button, you can supply the current, we can do organic reactions. So simply it's that in large scale also we can do n number of large scale. You can make it two large electrodes, keep it in big barrels or the container, just can supply that current or voltage. So the reaction is going to happen. So the industry level, so this electro-organic synthesis is going to be booming in future. So how that electrochemistry, I will tell you that 17th history of uh, how the electrochemistry is established. So this is the first person, Lunghi Galvani. He is the Italian physicist. He is during that 17th century. He was investigated. He is the first person investigated that conceived to be electricity in animal tissue. He's the first person is reported that the electricity is consumed in animal tissues. So this for that he is took frog experiment. So what is frog experiment? The experiment, the frog experiment that he's is connected, he's taking off two metals. So these two metals he connected in, one is in spinal, another metal is connected in ties. So what he done, so one metal he is connected in spinal, another one metal he is connected in ties. After this connection, so he connected of these two metals. He took the copper metal one side, another one is iron metal. See, he connected these two metals. When a connection of these two metals, the frog leg is going to be twisted. So this experiment, based on this experiment, what he convinced that, what he concluded that animal has the electricity. He is the first person is that find out that animal has the electricity. So he reported during the 17th century. After that, Alexander Volto, he's proved that it is metallic electricity. He is the Italian physicist. Is during that 17th and 18th century. He is the discovery of methane gas. Almost in the year of 1776 year. So almost he during this year he discovered that methane. So what he Alexander Walto is done, he repeated this Galvani's experiment, and he proposed that animal does not have the electricity, but it is electricity is produced by that metals. So he proposed that electricity is not coming from that animal bodies, instead of electricity is coming from the metal. So when it is connecting of these two metals, so this electricity is produced. So this electricity is passes to these animal tissues. So that means that electricity is going to be uh, conduct, that animal tissue is conducted. Whatever that galvanic experiment, Galvan is told that animal has the electricity. After Alexander Walto, he told that animal tissue, animal body has conductivity, not electricity. So that metal has the electron, the metal is going to produce the electricity. In order to prove his statement, he made a voltaic pile. What is voltaic pile? He made that zinc and copper rods. So these are the zinc and copper rod. The in between of that blue color one, that which is placed in electrolyte. So this electrolyte is called as animal tissue, or that whatever that animal tissues. He placed one is copper, then copper, zinc, then after that electrolyte. So like that he placed many metals and voltaic cells. After this connection of these two, that electricity is produced. So he proved that, so that animal tissue is conduct the electricity electrolyte, but that electricity is produced by these two metals. After the following that, Michael Faraday is the one British chemistry and physics. So combination of he is to do chemistry and physics. During that 18th mid of 18th century, he established two laws. One is Faraday's first law and second law. So what is Faraday's first law? Tells about the amount of chemical changes or decomposition is exactly proportional to the quantity of the electricity that passes to the solution. When the passes to the solution, how much decomposition is proportional to this, how much of current we have passed. So that is the first law he reported. After that, here is the same Faraday is reported. The second law is that amount of different substance deposited or dissolved by the same quantity of electricity are proportional to this chemical equivalent weight. So these are the two laws will help a lot for doing that electrochemistry. So after his laws, that he's the first person of gold is the first person is reported in 18th century itself is reported electro-organic reactions. So those previous one is that one is report of conduct the produce the electricity and conduct the electricity. He's the first person did electro-organic synthesis, that we can call it as gold method. So that I think everybody could study it in +2 level, the gold synthesis. This is the technique of making of hydrocarbons by electrolysis. The electrolysis is in between the electrochemistry, putting of two electrodes and passes to the current. So decarbonization, the carbon dioxide, the carboxylic acid is going to be carbon dioxide is getting eliminated, this R group, and another R group is going to be attacking. So this is making of hydrocarbons. So this, for that he made a number of hydrocarbons making of this electro-organic synthesis. He is the first person making of electro-organic synthesis. After that, so many revolution came on electro-organic synthesis, and not only electro-organic synthesis, electrochemistry. So many revolutions are came. So up to till date, we have two types of cells in electrochemistry. One is that voltaic cell, and another one is electrolytic cells. So what is the difference of voltaic cell and electrolytic cells? So the voltaic cell, right, produce the electricity. So this voltaic cell produce the electricity by the chemical reaction, with the help of chemical reaction. So when you are chemical reaction, so the chemical energy is converted into the electrical energy. So that is tells about the voltaic cells. What is the best example is that the battery. We know that those days we have the batteries are made of zinc and copper metals. So these metals has gives that electricity, so that that batteries will give the energy to the electricity to convert it into light energy, or chemical energy is going to convert it into electrical energy. So this is the battery is the best example of the voltaic cell. What is electrolytic cell? So the electrolytic cell is a direct opposite of the voltaic cell. That's all. So what is that chemical energy in voltaic cell? Chemical energy we are converted into electrical energy. Here in electrolytic cell, that electrical current is going to produce the chemical energy. So chemical reaction is produce the current. The current is going to be conduct the electrochemical reactions. So that means that electrical energy is converted into chemical energy. When applied current, the chemical reaction is going to be happened. So these are the different, but both are directly opposite. So what is the best example is that charging of the phone. So we have that phone, the phone battery, when you are plug it in current, it is going to be charging. So these are electrolytic cell, but when in torchlight, it is going to be the voltaic cell. So these are the simplest example of our difference of the voltaic and electrolytic cells. So these are the example of voltaic cell. Just I have only one slide of voltaic cell. So I think this everybody could study it in from +2 level. So that electrochemical representation, how that electrochemical is converted into electrical energy. So here two compartment reaction. One is that zinc is converted into zinc 2 plus. So when it is 2 plus, 2 electron is going to be exiting, releasing. So another one is another compartment is copper. Copper 2 plus is converted into copper. So the oxidation and reduction, during this oxidation reduction, this electron flow is going to be happen. So this electron flow, during this electron flow, that chemical energy is converted into electrical energy. So this everybody might know about this electrochemical cell. And during this electrochemical cell, we can study about electrochemical series. When that when electrical or potential difference, so based on this potential difference, we can make it which are the reagent is going to be oxidizing agent, or which are going to be that reducing agent. When that current or potential difference is positive, so that we can act as act as a strong oxidizing agent. When that potential difference is negative, we can use it as a strong reducing agent. So this, I think these are very +2 level syllabus. So now what I'm going to focus on electrolytic cells. So what is electrolytic cells? So I will repeat that. What is electrolytic cell? The electrolytic cell is nothing but when applied current, the current energy is converted into chemical energy. We know that. So that is nothing but electrolytic cell. How that chemical reaction is going to be happen? So this is the applied current is connected between of the two electrodes. This electrochemical setup is connected between of two metals. So these are the electrodes, the connected between of the two electrodes. So one is anodic electrode, another one is cathodic electrode. So when is connected, after this connection, when current is passes to this electrode, so this electron is going to be flow over on the electrode. So the electron, while this electrode, so this electron is going to passes to this anode to the cathode. So while the current it is going to be passes, so like when applied current is applying to this electrode, via this electrode, it is that electron is going to be passes to this another electrode. So another electrode is connected with this current. So this electron flow is going to be happened. So during this electron flow, so this electron is going to move over to either anode or cathode. So while moving over to this anode to cathode, this electro is going to be produced, that electrochemical difference of the potential difference is going to be happened. When moving off this electron, the potential difference is going to be happened. So during this electrochemical potential, so that we can call it as a current, also we can call it as current. So these two, that the difference of this electrochemical potential, we can do oxidation or reduction. For example, if you can taking off inside the substrate is taking off an electron from this when applied current passes to this electrode. So this electrode, so this substrate is going to be takes one electron or release the one electron. Either it is going to be oxidation or reduction. If it is leave of electron, it is oxidation, or gaining of electron, it is reduction. So the substrate may undergoes oxidation or may undergoes reduction. So substrate is going to be react on the surface, because surface has electricity, it is passes to the substrate. So these are the electrochemical basic concept of electrolytic reactions. So this electrolytic reaction has two type of electrolytic reaction. One is undivided cell, another one is divided cell. What is undivided cell? That these two electrodes are placed in same compartment, same vessels. So this oxidation and reduction takes place in same vessels. So there is no divider. So it is all the reaction, oxidation or reduction, everything is to happen in the same reaction vessel. But in divided cell is these two oxidation and reductions are separate, because you can see that one electrode is placed on one reaction compartment chamber, and another electrode is placed on another chamber. So in between of this is salt bridge. This salt bridge is going to be conduct the electricity. That's all. Is passes to this electron to our one compartment to the another compartment. So that means the oxidation takes place in one compartment and the reduction is going to takes place at another compartment. So these are the difference of undivided, the divided and undivided cell. We'll see that how that undivided cell is going to be work. So most of the organic reaction is to happen in undivided cell, because that we need all the substrate comes closer. But if it is in divided cell, right, one reaction is going to happen here, and that another substrate, one substrate we are taking here, so oxidation, the another substrate is going to be reduction, but there is no connectivity of two reacting of substrate 1 and substrate 2. So in undivided cell, it is possibilities of making coming closer. So then it is bond formation is going to be takes place between of the substrate 1 and substrate 2. So this is the setup of electrolytic cell reaction setup. You can see that. So this connection point is going to be connected with external power source, that is nothing but current. So this current is going to be supplied via this connection point. So this connection point is connected with one electrode, anode, and another connection point is connected with cathode, another electrode. This electrode is connected of this external energy supply. So this lid is, we can here we can place it if you want to reference electrode. If sometime that electro-organic reaction we can do anodic and cathodic electrode is sometime enough, but if you want to do exactly, need to have a reference electrode, so that you can place it in between of over here if you need of your reaction condition. So this lid is for opening and closing. So sometime if you want to add the substance or reagent or solvent, we can make use it here. So this colored one is that is going to be that solution. So that is we are going to be solvent and substrate, everything is dissolved, and after that we need to add the electrode. So this need to add the electrolyte. So this electrolyte is also important of this electrolytic cell, because need to conduct the electricity. So when applied current, it is passes to this electron is passes to and the electrode, then this electrode need to go and to reaches to another electrode. So then only that electron flow is going to be happen. So this electron flow need a support or electrolyte to carry this electron to the here. So sometimes that electrolyte is going to be is support the electron to carry from the one system to another system, or this sometimes this electrolyte carry this one electron or whatever that electron is pass it to the substrate. So this electron is going to carry and it is passes to the substrate is getting either oxidation or reduction is going to be happened. So these are the generalized why electrolytic cell has three major part. One is applied current, another one is electrode, and then electrolyte. So we'll see the one by one. What is electrode? What is the role of electrode? It is going to be a transfer of electron from this applied current. So this applied current, it is conduct the electricity, it is passes to this electron. The electron transfer is going to be giving. So this when your electron transfer is going to be happen releases. So that's why the main role of this electrode is need to conduct the electricity. So when the conduct the electricity, this electron is transferred there to the solution. That so that is the main role of this electrode. So when it is that conduct the transfer the electron, it should not react it to this solution, because otherwise this electrode is getting dissolved. So that means this electrode should be chemically inert. When that this electrode should not react it with this any electrolytic medium. So that means that this electrode behave as a heterogeneous reaction, heterogeneous catalysis. Because what is the heterogeneous catalysis? That the homogeneous is that all the reaction medium in one medium, but heterogeneous is different medium. So this is reaction is happen at liquid medium, and this electrode is in solid medium. So that heterogeneous reaction is going to happen. And this electrode is easy to handle, because when you're placing of electrode, you need to be handling and taking out. So this kind of electrode is needed, and it should be economically begin and environmentally beginning. So there is no harmless. So this kind of electrode is going to be good electrode. So this kind of electrode we have to choose it. So it has two kind of electrode. One is sacrificial electrode and another one is non-sacrificial electrode. If it is heterogeneous reaction, so there is no we can call it as non-sacrificial electrode. What is non-sacrificial electrode? It should be highly durable, it is stable, so there is no reaction happened uh, in that electrode. So it is reaction used to happen on the heterogeneous reaction used to happen on the electrode, but the electrode should not sacrifice his reaction. So that is what are the one platinum, carbon based material. So what are the carbon based? Graphite, glassy carbon, RVC. So these are the electrode is highly strong, and we can make it non-sacrifice. So there is no sacrification of the electrode. But we have some of the electrode has sacrificial electrode, because this sacrificial electrode, it is going to be that electrode is dissolved during that electrolysis. That electrode is going to be dissolved and make it homogeneous. That reaction is going to be happened. So what are the one? Aluminum, zinc, and magnesium. These are the electrode is going to be sacrifice that solid nature, and the reaction is going to be happen. So this kind of reaction also going to happen. Let's see one by one. So what is platinum? It is platinum is highly durable, strong. It is oxidative condition. So when oxidation reaction, so nothing going to happen, but it has a wide range of potential range. So that also needed. We need wide range. So if it is wide range, we can use of one platinum, we can do all the potential difference reaction. So generally we can make it this one as anodic material. Another one is graphite. It is nothing but highly the carbon based material. It is also highly stable and oxidation, and it has this graphite also has a wide range of potential difference. We can do a number of organic reactions. And so the what is the glassy carbon? It is also carbon based one, but it is amorphous carbon. So the difference of the carbon is glassy carbon. It is amorphous and very very strong hardness. So it is chemically stable and it has wide potential range. We can do either graphite, or otherwise you can use it glassy carbon. So that also going to be, we can use it. And that RVC is reticulated vitreous carbon. It is nothing but RVC. It is the foam form of glassy carbon. So this is the glassy carbon that it is foam form. So this glassy carbon is comes like rod type, but RVC it is like foam. When it is foam type, it is has large surface area. When it is large surface area, the reaction is to happen fastly. So that's why that generally we used to use RVC, because most of the organic reaction needs to happen on the surface. So that means we have more surface, the more reaction is going to happen. If it is less surface, the reaction is too slow. So that means the RVC has large surface area, we can do in fast reactions. So these are the electrodes, choosing of the electrodes. So what is the choosing of the electrolyte? So this is the electrolyte. It is going to dissolve the substrate. Sometimes the solvent as well as the electrolyte is going to be same. Sometimes the solvent itself act as a electrolyte. So what is the electrolyte? It is going to dissolve the substrate 1 or substrate 2 to make it homogeneous, and then this electrolyte is going to be dissociation in nature in solvent medium. So in this dissociation, that it passes to this conduct the electricity to one electrode to another electrode. So what are the electrolyte? Lithium perchlorate, acetic acid, sulfuric acid, uh, uh, ammonium perchlorate, and these are the one is anionic electrode, and the cationic electrode is cottonized. So wherever that cottonized perchlorate, ammonium trialkyl ammonium salt, so these are the one is cationic, the remaining perchlorates are anionic perchlorate. Whatever the based on your reaction condition, so which kind of electrolyte need to be cationic electrolyte or need to be anionic electrolyte, you have to choose accordingly your reaction nature. So sometimes acid and bases, sometimes simple acid and bases also going to be support the electrolyte, so that we can call it a supporting electrolyte. So it is also facilitate to conduct the electricity much more faster. So that's why supporting electrolytes also going to be support. So another major compartment is applied current. So these are the very very important in the electro-organic synthesis, because it is going to be influence major influences in the electrolysis. So when it is completely, it is represented number of equivalents of the reagent or catalyst. This applied current is completely replaces or equivalents to this of the reagents or current as a equivalents of the reagent or catalyst. So when you are adding of reagents, that more reagent, the reaction is going to be faster. When you are adding of more catalyst, reaction is going to be faster. So completely it is controlled by that current. When similarly that current is going to be same, when you are applying current is directly proportional to this rate of the reaction, the current density which is controlled the speed of the electrochemical process and temperature also. So the rate of the reaction is completely is controlled by that applied current. When it passes to higher energy, the reaction is going to be faster. At the same time, need to be very careful, right? That reaction medium should not affect when giving off more current. So that means we need to give optimized current is important, because when you're passing more current, sometimes that electrode is going to be destroyed or going to be denaturized, or sometimes the reaction is going to be confused, getting decomposed. So these are the substrate. When you're adding applying more current, sometime it is going to be decomposition is nature is going to be happen. So that's why the applied current is major influence. Sometime we can control the product also. So when it is applied mild current, so it may cause us to particular the selectivity is going to be happened. So when giving of current that minimum energy, some kind of reaction is going to be happened. So when increasing the current, so that the chemical selectivity is going to be vary. So you may end up with the different product. So that for selectivity, specificity, and rate of the reaction, this applied current is going to be major role in during the electro-organic reactions. So these are the basics of electro-organic synthesis. How the so far what we have seen about how electrolysis. This electrolysis, we have three parts. Major part one is electrode. So that is important because that where that electrode is reaction surface reaction is going to be happen. The electrolyte is important. It should conduct the electricity. And then applied current also important because we need to control the rate of the reaction, and we need to control the temperature, and we can control the equivalence of this reagents. So how so these are the setup reaction and how it is going to be application of the electro chemistry. So we know that these are the application many, not only this one. So I'm listed very few, and n number of applications are available in electro chemistry. One is batteries and fuel cells, sensors, water splitting, electroplating, and the electro-organic synthesis. Where I'm focusing here is that electro-organic synthesis and purification of the metal and industrial chemicals. So and etc. A number of applications are available. So just I'm for few I'm picking out here. So these are the batteries. We know that this battery is placed or here. So this is the best example of voltaic cell, or we can call it as galvanic cell. So I'm skipping because I need to go for electro-organic synthesis. Just I'm giving a basic introduction. Electroplating method. So this electroplating method, we can plating over one metal to another metal. So the best example is that jewelry uh, shop, the covering jewelries. So they used to that gold is plated on the another metal. So on the surface we can go coat the either copper or gold. So we can easy to electroplating method, we can do reaction the coating the metal gold plating we can do on the surface of the jewels. So the that is the one. And purification of the metals. So we can if the metals are impure, so we want to purify it. So this we can call it as sacrificial electrode. So this sacrificial electrode is getting dissolved. So when it is going to be dissolved in nature, whatever that impurity metals, that impurity is getting deposited, that dissolved metal is going to deposited on the another electrode. That if it is anode, that cathode is getting deposited. You can see that another picture. If it is impure electrode, metals is getting dissolved. So this is impurity, and this one is an deposition, pure purification of the metal is happened. So this is another process. uh, yeah, this is the one is started of chemical reaction in the industry level, right? So we know that sodium hydroxide. Can you guess how that sodium hydroxide is producing? It is easiest simple source of sodium chloride. So this sodium chloride is available from the natural seashore source. We have sodium chloride commercial one. We can take it and just dissolve it and do electrolysis. While electrolysis, so this chloride is gas is getting eliminated, we'll get it sodium hydroxide. And not only chloride and hydrogen gas also getting eliminated, we'll get it sodium hydroxide. So this is the way can make it pellet. It is going to be white solid, so that you can make it. It is available for research purpose or commercial purpose. And another industrial process, excuse me, industrial process is making of aluminum. This we can call it as Ralt process, that aluminum production. So we have that aluminum ores, aluminum oxide ores is available in natural. So you can there we can take it out from aluminum ores in nature and passes to this carbon. That carbon is that aluminum oxide, oxygen is getting taking out, and carbon dioxide is getting out. Only that pure aluminum is getting deposited. So this is the aluminum. So this reaction is to happen during electrolysis process in industrial scale level. Another industrial scale level is that we know that well-known example, the everybody knows about polymer of nylon 66 rod or thread. Nylon 66 thread is very very strong. You can see that wherever you can see that nylon rod. It is polymer of uh, adiponitrile. So this is the adiponitrile. So this polymer unit is nylon 66. So this adiponitrile is the precursor of nylon 66. For synthesis of this adiponitrile, we need to have dinitrile and electrolysis. By this electrolysis, so we can do adiponitrile synthesis for making of nylon 66 process. So these are the simple one I'm covering. So now I'm going for electro-organic synthesis. Is it time is okay, ma'am, or I need to finish it? Madam, Manonmani, madam.
Sir?
I'm taking. So it is time limit or need to?
No, sir. No, sir. It takes 15 minutes. You can take, sir.
Okay, okay. So
Thank
just
you,
I
sir.
have electro-organic synthesis. Just I will go a little fast because I'm taking more time.
No,
It is
sir.
almost.
It take up to 12:20 and so on.
Okay.
We will
Anyway, I
start
will
at
try to
11:20 only. Yeah, yes, sir. Yes, sir.
I will try to speed it up.
Yeah, yes,
Just
sir.
just now I have started electro-organic synthesis. Just I gave up to these basics.
Okay,
What
sir.
is that organic reaction means? You know that organic oxidation and reduction, or sometimes aromatization and functional group transformation, or cyclization, or coupling reactions. So I will simply will cover what is oxidation reaction. We can call it as removal of hydrogen or addition of hydrogen. Here you can see that a removal of these two hydrogen, it is getting oxidation. Alcohol is getting oxidation to ketone. So when you are doing of this alcohol oxidation, need to have either chromium or uh, so a lot of reagents are available, but that reagents are metal based one or reagent based one. So either we have to use it metal or other light, sometime light also going to be, but electrochemically can possible, because that when to remove of these two hydrogen by on the surface, we can do oxidation. So these two hydrogen elimination as H2 gas. H2 is environment beginning one, so that's why there is no harmless. So all the one is green approach. So that oxidation, and you can see that addition of hydrogen reduction also we can do. So what is this one? Is nothing but Birch reduction. So that my MSc level textbook level chemistry, that aromatic ring in Birch reduction, it is going to be 1,4 dihydro system of diene. So this one can also possible when taking off magnesium and galvanized steel wire. So these are the electrode is placed in taking off benzene or substituted benzene. It is going to be reduction is going to be happen. Addition of hydrogen, it is going to be reduction. These are the coupling reaction that this also going to be textbook chemistry. It is going to be coupling reaction of carbon carbon bond formation. The alkyl halide and vinyl, it is Heck coupling. So this generally this Heck coupling is going to be on palladium, but it is going to be happen. We can do it on electrolysis method, and this also going to be coupling reaction. So this also we can do electrolysis. Next one is CH activation. So the recent years, the CH activation is well booming one, because activation of aromatic CH bond is not easier. We can make it aliphatic CH bond is easier, but aromatic CH bond, because it is sp2 CH bond. So when it is sp2 CH bond, this CH bond breaking is not at all easier. So if you want to make it CH bond cleavage, so either need to have palladium or ruthenium or rhodium. So expansive reagents are needed for CH activation, but this can possible on the electrolysis on the surface of the platinum or RBC. This CH bond is breaking and making of CH bond, CH activation. So that is the one is familiar Ackerman. He is making of CH bond on electrochemistry. So this is carbon dioxide. So that carbon dioxide, this is the environment. When you are carbon dioxide is making of useful compound is very useful, because carbon dioxide environmentally it is going to be spoil our environment. So wherever that chemical industries are producing carbon dioxide, so that is going to environment, so that causes many environmental impacts. So in order to control this carbon dioxide, whatever that industrial wastage of elimination of this carbon dioxide, so that we can do electrolysis, just taking out that carbon dioxide gas passes to this chemical reaction, and on the electrode we can make useful of some organic compounds. So that means this carbon dioxide liberation to this atmosphere is completely, we can stop it. So that's why this electro-organic synthesis also going to be more impact, are going to be more useful in environment impact also. And it can possible of total synthesis of cyclization. We can see that under electrode RBC and carbon electrodes, this carbon carbon bond cyclization is going to be happen. You can see that it is going to be making of carbon carbon bond formation. So this cyclization is based on that electrolysis. You can see that it is going to be cyclization. So by making of carbon carbon bond, the cyclization of 6-membered ring is going to be forming. So this can also can possible on electrolysis. So having this one, so we have started our own laboratory. We have started working on electrolysis. So this is the first lab report on organic biomolecular chemistry in 2021. So we also started working on electrolysis, electrochemical organic synthesis. So what we decided, we thought that why not we can think about Baldwin theory. What is Baldwin theory? The Baldwin theory is it is MSc syllabus. It is available in MSc syllabus. What is Baldwin theory is that nucleophile is hitting to either sp carbon or sp2 carbon or sp3 carbon. If it is any nucleophile hits to sp carbon, so that we can call it as dick. So when that any nucleophile hit to sp carbon, that need to cyclization. Not only it is completely, it is Baldwin theory will tells about cyclization, not for nucleophilic addition. So this nucleophile attack to triple bond alkyne sp system. So if it is that kind of addition, it is gives cyclization, that is we can call it as dick. If it is a double bond, that is dick. So these are the double bond and triple bond is going to be mostly, it is going to be influence on Baldwin organic reaction. So that's why the Baldwin is proposed. If it is nucleophile hit to sp carbon, so that is dick. If it is sp2, that tick, that we can say, right? Okay, so now here we have sp carbon. So this sp carbon, this nucleophile can hit it to that inner sp carbon or exterior sp carbon. So we have two possibilities of attacking that. Why is attacking via a pathway or Y is attacking on P pathway. If it is A pathway, the double bond is going to be getting out. So it is getting outside the ring. That's why we can call it as XO. If it is that functional group is going to getting out of the ring, it is called it as XO. If inside, if Y is attacks via B pathway, so the double bond is within the ring, that is, we can call it as endo. So the what is the membered ring? 5 is nothing but it is going to be 5 membered, and if it is 6 is nothing but 6 membered ring. So it is end up with 5 membered ring and 6 membered ring. So this is we have idea to making how that electrochemistry it is going to be exodic cyclization or endodic cyclization. So that is the one. So having in mind, so we started and started literature. Taking this substrate, you can see that amide and alkyne. So this is sp carbon, we have amide. So amide can attack nucleophile to this sp carbon of alkynes. When it is attacking to this alkyne sp carbon, we can call it as dick cyclization. So this is dick, but where it should attack, it should the nucleophile, it should attack to this carbon or this carbon. If it is attacked to this carbon, double bond will go out. So that is XO. It is going to be 5 membered double bond, 5 exodic cyclization. If nucleophile attack to this carbon, it is part of the double bond is part of the ring is going to be 6 membered. It is 5 endodic cyclization. Fine. So these are the concept. So for functionalizing the making of activation of this triple bond, we need a halogen. This halogen generally it is going to be needed X plus, because the alkynes are electron rich system. The halogen need to be electron deficient one, so that it is coordination is going to be happen here X. So then only that nucleophile easy to come and attack here. So how to make it this X minus? So X minus, you can take it bromine or iodine or halogens. The halogen is to make it X plus and X minus. Halogen is to gives two ways. One is X minus and X plus. That X plus is going to be reacted over here, and cyclization is going to be happen. Or otherwise iodochloro, iodocl minus I plus, or n bromosuccinamide gives bromide minus. So these are the one is going to be free functionalized. One is going to be making of X plus. So that X plus is going to be reacted over to alkyne, and then nucleophilic hitting cyclization is happened. So that is the previous report. These are the report on thermal. And so taking off X plus, so what is the another product is going to be X minus. Sometimes this X minus may reacted with substrate, it undergoes some another product, and taking off X minus is going to be waste of the product. So taking off bromine, iodine, so these are the expansive one. Instead of that, we can take it like X minus. So X minus is easily available. You can make it sodium chloride, sodium bromide, and sodium iodide. So these are the sources commercially available. Taking off X minus to make it X plus, and we can do perform reaction. So this X minus anion to oxidation will convert it into X plus. Then X plus is going to be reacted to this alkyne, and cyclization you will get this product. For this conversion of X minus to X plus, we need oxone and base. So this oxone is going to be removal of this hydrogen to make it X plus. So the X minus to X plus need to remove two electrons. These electrons are removed by oxone to from X minus, oxone removed two electron, it is going to be X plus. So that X plus is going to be bonded with a triple bond, then cyclization. So these are the up to this one is thermal. It is previous report. What we had idea? We had idea is that electrochemistry has the surface. We have electrode. The electrode can conduct the electricity it can produce this electron. That electron is going to be reacted over here, then it generate x, x plus. So either electrode can takes the electron or reduction or oxidation. A leave off, and the electrode is getting a leaving of electron is oxidation or gaining of electron. Here that x minus, the electrode is taking one electron, x minus to x dot, then taking one more electron by electrode, you will get it x plus. That's we had idea in mind. So we started working on electro chemistry. Then we succeeded when you are taking off sodium chloride, bromide, and sodium iodide, the simplest salt, that is x minus, we can convert it into x plus on the surface of the platinum electrode. We have chosen both are platinum, so we can deposit anode cathode is on the platinum, and then we have supplied the current, and we have established that exodic cyclization of the product. So what we have done, so we have removed that base and oxone. Oxidant we have removed, and base also we have removed, and we have performed an electrochemical reaction. So these are the condition, right? We have tried this optimization table. So far, well, the best one is for sodium chloride, sodium bromide, and iodide is platinum electrode is best one. We have screened all the electrode. Carbon electrode we have screened. RVC platinum also we have screened, and carbon platinum. But among all the electrodes, platinum is the best one. And you can see that when passes the different current, you can see that when passes the current, 12 microampere is more than enough. That 10 microampere is to gives 84% of the product. So when it is 12, there is no difference, but when you are reducing the microampere, the yield of the reaction is going to be reduced. The what is the best one is 10 microampere, and the platinum is going to be that electrode, and these are the lithium perchlorate is the electrolyte to conduct the electricity. So that you can see many array of the substrate. So you can see that different substitution of n substituted one and alkyne triple bond substituted one we have achieved, but the what is the source is we have choose sodium iodide. You can see all the iodide substituted with the electron donating, withdrawing, aliphatic, heterocycles, all the substrates are working well, we have reported. And then sodium bromide, taking off sodium bromide, you can take bromo substituted one. So we have succeeded all the substrate donating, withdrawing, aliphatic. So it is almost working all the electrochemical system. And you can see that sodium chloride also, we have one example of sodium chloride also, but comparatively iodide is better reactivity and bromide than chloride. Chloride is to give only 41%. So comparatively the iodine is going to be more reactive than chloride. So this is the mechanism how the reaction is going to be happen. We know that this is the electrochemical cells is connected of anode and cathode electrode. Platinum, this is also platinum. So when applied current is passes to here, right, that sodium chloride or bromide iodide is gives x minus. So this x minus reacted on the surface of the electrode, it releases one electron, it loses that x minus loses one electron, become x dot, and again it is reacted with one more loses the electron, it become x plus. So this x plus is going to be coordination with this alkyne, has two type, this x radical addition to this alkyne or x plus is addition to this alkyne. Two pathway, one is if it is x radical is attacked to this alkyne, so this x radical and alkyne has that covalent bond is one radical from here and one radical here. So this radical and the x is going, we can make it carbon x bond, and we have one radical over here. So after this one, the removal of one electron, we will get plus, or otherwise this X plus is directly connected to this alkyne, we can make it directly the product of alkyne plus. If it is alkyne plus is formed, this nitrogen is going to be resonance become O minus. So this O minus act as a nucleophile. It is comes over hit to this carbocation. We will make it 5 exodic cyclization of 5-membered furan ring systems. So then whatever that the removal is that H plus, what is the only one removal product is H plus. So this H plus is reacted with another cathodic surface, will get it H2 gas. So this is, there is no harmless, it is environment friendly gas, it is getting eliminated, will get it the product. So this is the mechanism. So this is the first report we have reported, but still we are working, many project is going on. So my topic is completely visible light mediated reaction. After visible light mediated reactions, I'm switch over to this electrochemistry. After switch over, this is the first publication. Then I have lot of publication to publish. So that's all my top presentation. Thank you for your listening. If you any question, please ask.
Thank you, sir. Sir, I'm sure that your lecture on basic concept of electro-organic synthesis is an enlightening speech which sparks the young graduates and research scholars to get interest in research area. Thank you, sir. Now, this platform is open for question and answer session. Participants are encouraged to post your questions in the chat box. Kindly mention your name and institution address.
If any question, feel free and ask. Students?
Hello, sir.
Yes.
Students have posted few questions in the chat box. So
Can
may I
you
read the questions?
Yes, ma'am.
So what is the advantages of reference electrode in components of electrolytic cell? Can you explain the range value of applied current?
Yeah, when you want to use of reference electrode, the accuracy of the generally when you are electrochemical react want to do electrochemical record electrochemical workstation, that reference electrode is needed because that is going to be reference to be where that oxidation or where that reduction. For electro-organic synthesis, I think reference electrode is not necessary, because we are doing reaction on this inside the reaction. But if you want to record CV, that or you want to record or you want to sensing sensor or other application, the reference electrode is needed. I think for organic reaction there is no need of reference electrode. So within anode cathode is enough for doing electro-organic synthesis.
It's posted by Jayashree. That is, from the webinar, it is clear that the conservative method, electro-organic synthesis method, has more advantages. Then why it is not practiced more in realistic?
Yeah, it is a good question. In future, right, most of the industries or most of the researcher, they are going to start on electro-organic synthesis. The recent year, the electro-organic synthesis is going to be booming. In another 10 years, the electro-organic synthesis is going to be reaches to everywhere.
Posted by Meghavardhani. Is electro-organic synthesis a sustainable one?
Yes, it's true, because it is we can by applied current, just you can switch on, we can do the reaction. That's all. You can make it set up, just switch on, will get the product. You can take it out and purify it, and our industry level you can make it bulk quantity also. It is completely sustainable one. Yes.
Thank you, sir. Next question. Why carbon-based electrodes are more useful in electro-organic synthesis?
because the carbons are not reacted because it is solid one, stable one, and it has wide potential range. So some of the chemical reaction has a particular potential, and some of the chemical reaction has another different kind of potential. So we need electrode which is have wide potential, so that using of one electrode we can do all kind of reactions. So that's why carbon based electrode we are choosing.
Thank you, sir. So next question, can environmentally hazardous gases like HS gas be put to good use through electrochemical process?
No, it can that electrochemical process produces H2 gas, not H2S gas. H2 is more environmental beginning, but not H2S. Sulfur is not environmental beginning gas.
Okay, sir. Thank you, sir. Then, why does an electrochemical cell stop working after some time? Posted by Abhinaya S. Sir.
Why does an electrochemical cell stops working
After some
after?
time.
I'm not
So,
getting.
when, that is, I think they are asking from the electrochemical cell. Why does an electrochemical cell stop working after some time? They posted.
No, it won't stop it in between. We can
So when you
continue.
so as
We
far
can.
as
You
while
can.
we are passing current, the electrochemical reactions will take
Yeah,
place.
yeah, it takes place. No need.
Yeah.
Even we used to perform 48 hours also. We can continuously we are supplying this reaction going
Okay.
on.
So as per the current we are supplying, it's work on. Yes,
Yes,
no, sir.
yes, yes, yes. Just we are giving microampere current. That's enough. Very, very, very less energy is enough for doing organic synthesis.
Okay, sir. Thank you, sir. The next question, is this an efficient method than using reagent, catalyst, etc.?
Yes, yes. Of course, it is efficient method because if you want to use reagent, it is very very expensive, and catalyst also expensive. All right, after that reaction need to remove this reagent and catalyst. Sometimes these reagent and catalyst may cause us some side products major, but in electrode it is heterogeneous, so there is no side product, so there is no only you may chances to get only one product. Rather, if you can use a direct reagent and catalyst, you may chances to a number of product. Then it is going to be purification also going to be problem. So that's why this electro-organic synthesis is best with it.
So thank you for your answer, sir. The next question posted by Sedu Madhavan Sudha Parimula, madam. Can we achieve carbon atom efficiency by electro-organic synthesis?
Carbon atom efficiency. What? What's the question? I'm not getting.
Uh,
Carbon atom
yeah.
efficiency.
Can we
What do you?
achieve can we achieve carbon atom efficiency by electro-organic synthesis?
Actually, I don't know what is carbon atom efficiency. Why want to calculate that carbon atom efficiency? That also I don't know. Maybe I think I don't have correct answer for this one. Maybe you can ask to right person who is working on complete electrochemistry. I'm not
Okay, sir.
electrochemistry guy. I think you are related to electrochemical reactions. I think you can contact to electrochemistry guy. I'm organic guy is touching of electrochemistry. Maybe I
Ah,
don't have clear answer for how to achieve carbon atom efficiency.
okay, sir.
Are you asking about CH analysis?
Sir, it may related to electrode. I think that is they are achieve how they achieve the carbon atom efficiency related to
Mm,
electrodes.
I
They
don't
are
know. It is new to me because I'm organic
okay, sir. Later
background.
we can get an
Okay.
answer, sir. Okay, sir. The next
Okay.
question posted by Abhinaya is how to avoid pH changes in synthetic electrochemistry.
Yeah, it's a good question. Sometimes the pH also needed for doing organic reaction. Sometimes reaction used to happen and acidic medium. Sometimes reaction used to happen and basic medium. It depends upon the electrode and the nature of the reaction. Sometime when you are changing of the pH, the electrode may be decomposed or sacrifice this electrode. So that accordingly you have to choose the pH, or you have to generally you have to make it neutral pH. That's generally best way to do organic reactions. Don't go for more acidic and don't go for more basic. Try to maintain in between of 5 to 8, so that's better.
Okay, so thank you for your answer, sir. Next question.
Thank you, sir. Thank you, ma'am. Now I invite Dr. S. Bhardi, Assistant Professor, Department of Chemistry, to give the vote of thanks.
Yeah, just a minute, ma'am. I will finish it. Hello.
Sir? Tell me,
Shall I
sir.
say a few words?
Yes, sir.
Okay. I will give the thanks to Kirti, Manonmani, and Bhardi for inviting me. Who is the Kirti is introduced to the Etraj College for these are the organizing member, and I thank Vijaya, head of the department and co-convener, and I also thank S. Kodai for convener and principal secretary for giving this opportunity. Thank you.
Thank you, sir. Feeling gratitude and not expressing it is like a wrapping a present and not giving it up. On behalf of PG and Research Department of Chemistry, Etraj College for Women, it's pleasure to propose the vote of thanks. First of all, I thank to the Almighty God for making today's webinar a resounding success. I deem it a great honor and privilege to propose the hearty vote of thanks to our resource person, Dr. R. Anandhan, Assistant Professor, Department of Chemistry, University of Madras, Guindy campus, for graciously accepting our invitation. Sir, your explanation on brief introduction of electrochemistry-based organic synthesis and its application in industrial area is more informative and well-groomed. So today we had an opportunity to hear your thoughts, and we thank you for thought-provoking webinar session on basic concept of electro-organic synthesis. Thank you, sir. I immensely thankful to our management and our principal and secretary, head PG and Research Department of Chemistry, Dr. S. Kodai, and our vice principal, Dr. D.B. Usharani, for giving permission and guidance to conduct the national webinar. Thank you, ma'am. I extend my most sincere thanks to our head in charge, Mrs. M. Vijayam, Associate Professor, PG and Research Department of Chemistry, for her constant support and encouragement, which made the webinar the grand success. Thank you, ma'am. I owe special thanks to our senior faculty members and our colleagues of the Chemistry Department for their valuable suggestion and unstinted support in organizing the webinar. Thank you all. I would like to acknowledge and thanks to S. Makavi, Association Secretary, and N. Kayalvili, Joint Association Secretary, 3rd Basic Chemistry, for their immense support and cooperation for making this webinar a grand success. Thank you, students. Last but not least, I thank all our participants who make this event a memorable, a remarkable, and resounding success. Thank you all once again. Now, we end this session with our college song.
உயர்வை நாடும் உள்ளவே உயர்ந்ததென்று போற்றுவோம்.
அறிவும் ஓங்கும் செல்வ நிதியமும் மடி திறந்த வெள்ளம் போல மனமு வந்து நல்கினார். அழுதையர்கோர் கல்வி கோயில் மாண்புடனே நிறுவினார். கொடை வளலாம் எத்திராஜன் கொள்கை வழி செல்வமோ ஏறுவோம் முன்னேறுவோம். பாட்டுடனே அறிவியலும் பல கலையும் பயிலுவோம். நாட்டினிலே அறத்தை காக்க நல்லொழுக்கம் கூடுவோம். ஏட்டினிலே கற்ற கல்வி என்றும் எங்கள் நெஞ்சினில் கூட்டும் தெய்வ பக்தியோடு தேச பக்தி ஓங்கவே ஏறுவோம் முன்னேறுவோம். வயது தெய்வ தீபமாக ஒளிரும் கல்வி சுடரினை முயன்று தேடி காணவே முன் வைத்த கால்பின் வாங்கிடும். முயன்று தேடி காணவே முன் வைத்த கால்பின் வாங்கிடும். முயன்று தேடி காணவே முன் வைத்த கால்பின் வாங்கிடும். ஏறுவோம் முன்னேறுவோம் என்றுமே முன்னேறுவோம். எங்களிடத்தில் ராஜ் கல்லூரி ஏற்ற வாழ்வு தேடுவோம். ஏறுவோம் ஏறுவோம் முன்னேறுவோம் முன்னேறுவோம். ஏறுவோம் ஏறுவோம் முன்னேறுவோம் முன்னேறுவோம். ஏறுவோம் ஏறுவோம் முன்னேறுவோம் முன்னேறுவோம். ஏறுவோம் ஏறுவோம் முன்னேறுவோம் முன்னேறுவோம்.
Thank you. Dear participants, I request you to all stay back for a few minutes. The link for the feedback form will be posted soon. Kindly fill the feedback form to receive your e-certificates. Thank you. Thank you, sir. And thank you, teachers.
Yeah, thank you. Shall I leave?
Yes, sir. You can.
Okay,
Thank you,
I'm going to exit. Okay.
Okay, sir. Thank you, sir.
Okay, thank you.